Okay, you guys, so I want to talk a little bit about sex-linked traits. As you saw in the video before, the study.com video, which you either had to watch on your own by just clicking that link, or the sub would have shown it to you. So sex-linked traits are traits or genes that are carried on the sex chromosome. So if you guys remember, you have a female has 2 X chromosomes and a male has an X and a Y chromosome. So there are some genes or genetic disorders that can be carried on either the X chromosome or on the Y chromosome. Now don't forget, the Y chromosome is quite small compared to the X chromosome. The X chromosome has a lot more room to carry a lot more genes on it. So different disorders or these different traits can be carried on the X or Y chromosome. And I just want to talk about 2 of them that are pretty popular that are carried on the X chromosome. So hemophilia, this is a trait, or I should say this is more like a disorder in which somebody does not have enough clotting factor in their blood. So if you fall down and if you scrape yourself, a lot of times when you bleed, of course, it's going to scab over and eventually your cells will repair themselves and that scab will go away. Well, if you have hemophilia, you do not have enough of that clotting factor in your blood to scab up and to scab over. So a lot of times somebody with hemophilia, if they get cut, they're going to have to be rushed to the hospital in order to control the bleeding and make sure that they don't bleed out. Well, hemophilia is a pretty famous X-linked trait. So that means that the chromosome or the gene is carried on the X chromosome. It is not carried on the Y chromosome. So hemophilia is an X-linked trait. Okay, we represent it with 2 different alleles. It does show dominance and recessiveness. Okay, it's a recessive trait. So in order to see hemophilia, you have to, if you're a female, you have to have 2 of the recessive alleles. Okay, if you're a male, you only need 1 recessive allele. So we are going to use our capital letters and our lowercase letters to represent dominant and recessive, but we're going to use it on the X, and we're going to use the Y chromosome to represent a male. So let me give you an example here. So let's start with the genotypes. Let's see if you can see it here. So our genotypes are going to look like this. You can have a female that looks like this, 2 X's. She could have a dominant allele and a recessive allele, and she's considered a carrier. That means she carries the gene for hemophilia, but she does not have the gene, or she does not have the disorder, I should say. You could have a female that is homozygous, and this woman does not have hemophilia. Okay, so if you have the dominant allele, and if it's paired with the recessive allele, a woman could be a carrier because she could carry the gene for hemophilia, but does not have it because she has the dominant allele. You could have a female that has the 2 dominant alleles and she does not have hemophilia. Okay, you could have a female who has the 2 recessive alleles and she does have it. She does have the disorder, and you're going to want to write all of these genotypes into your notes. So those are the females. Coming down here, and I'll move this up a little bit, you can have a male who has a capital H on the X chromosome, and that male does not have the disorder. Okay? Males cannot be carriers. So I'm going to write that. Males cannot be carriers. Okay? Because they either have the disease or they don't have the disease. You could have a male that has the lowercase h, and the guys only have to have the 1 recessive allele to see it, since they don't have another X chromosome. And then, whoa, let's Try that again. So this guy does have hemophilia. Okay, so these are the genotypes that you need. So in your notes, not only should you write this down, but you should also write all the genotypes, or else you're going to have a hard time working the problems. So let's look at this, these problems. So it says, cross a man who has hemophilia with a woman who does not show the disease and is not a carrier. So we are going to use a Punnett square. Looks like this. Cross a man who has hemophilia. So the man is going to have an X and Y, who does not, let's say cross a man who has hemophilia. So he's got the lowercase h. With a woman who does not show the disease and is not a carrier. So she has to have two X's since it's a woman, okay? She does not show the disease and is not a carrier. So that means she has two capital H's. If she was a carrier, we would have capital H and lowercase h. So now we're going to put our genotypes together like we've done in the past. Just like this. So these are all the possible combinations. We could have a female who's a carrier. We could have a male who does not have the disease. We could have a female who is a carrier, and we could have a male that does not have the disease. So it says, what are the chances they will have a boy with hemophilia? 0 out of 4. Okay? Both boys are going to inherit the dominant gene. So that's letter A. Letter B, what are the chances of having a child that is a carrier of a disease? Okay? So males can't be carriers. They either have it or they don't. So in this chance, okay, we have 2 out of 4 that could be carriers. So that's hemophilia. Again, if somebody has the disorder, they do not have the clotting factor in their blood. Okay, so we have another one similar to that. We have something called red-green color blindness. Some of you guys might have red-green color blindness. It is an X-linked trait as well. So red-green color blindness, person has the inability to see reds, greens, and some yellows. Okay, it is an X that says line, that should say linked. It is an X-linked trait. So that means the red-green color blindness disease is going to, or trait, is going to be found on the X chromosome again. Okay, it is a recessive, I should add that in there somewhere. It is a recessive trait, or a recessive disorder, if you want to think of it like that. So you have to have 2 of the lowercase c's to see red-green color blindness. If the guy has 1 dominant allele, he'll have normal eyesight. If the woman has 1 dominant allele, she's going to have normal eyesight. Okay, so same thing. Our genotypes are going to be very, very similar. Let's start with the females. Our first female, let's say we're going to use capital C's. If she has 2 dominant alleles, she'll have no red-green color blindness. Okay, you can have a female that has a capital C and a lowercase c. She's a carrier. Same thing. So carries the allele, but no disorder. So that means that she carries the gene for red-green color blindness, but she does not have red-green color blindness. If you really were to ask around, the highest probability of people having red-green color blindness is going to be males. You don't see it that often in females because the female has the option to be a carrier or to be homozygous. The male can only have 1 of the alleles. Okay, so carry on down here. So in order for the woman to have red-green color blindness, she needs 2 recessive alleles. And I'm going to say has disease. And let's look at the guy's genotypes. Again, a guy cannot be a carrier of an X-linked trait. The guy could have a capital C, and he will have no disease. Easier than writing red-green color blindness. And you could have a guy that has the recessive allele, and he has the disease. So our letters are different, but our combinations are similar to hemophilia. Okay, so cross a man who is afflicted. We'll put our Punnett square right here. Cross a man who is afflicted with red-green color blindness with a woman who is a carrier. So if he's afflicted, he has to have the recessive allele. And with the red-green, with a woman who is a carrier. So if she's a carrier, we're going to have the capital H and the lowercase. Oh, just kidding. We're back to C's, not H's. Goodness, my brain is foggy. Capital C, lowercase c. So we're going to put them together. There we go. So A says, up above, what proportion of their offspring will have the disease? So she will not have the disease because she's a carrier. She has the dominant allele, which will mask it. He has a dominant allele, so won't see the disease. Since she has 2 recessive alleles, she is going to have the disease. And since he has the 1 recessive allele, he'll have the disease. So what proportion of their offspring will have the disease? That will be 2 out of 4. And letter B, what is the probability they will have a girl with the disease? So girl with the disease is 1 out of 4. Okay, so make sure you wrote all of this information down. You do not necessarily have to write the problems down, but hopefully you wrote the examples down. But you need all of these genotypes to help you work some of these problems. Okay, guys. So you're going to finish your incomplete dominance, codominance assignment, and you can turn that in. And then you are going to start one assignment, and that is worksheet 7.1, and I will make sure the page numbers are on Google Classroom or on the board. Thanks, you guys. Hey, I moved my paper in case you had a hard time seeing, so you might have to rewind this video and start over. Well, not start over, but you might have to rewrite a few things down. Okay, you guys, be good.